Let's talk about graphing. In 12.1, you should have graphed some exponential functions. Now we're going to graph an exponential function, and we're going to graph the logarithm with the same base as the exponential function, and we'll see how these are related. The exponential functions and the log functions are what we call inverse functions. And essentially, that means that when we graph the exponential, the inputs then become the outputs of the log function, and the outputs of the exponential function become the inputs of the log function. So, as you'll see, we're going to switch our x and y variables at numbers-wise as we do this. So if we're graphing 3 to the x and x is -2, that's 3 to the -2, or 1 over 3 squared, using the rules of negative exponents, which is 1/9. If we put -1 in, we get 3 to the -1, which is 1 over 3. If we put 0 in, remember anything to the 0 power is 1. If we put 1 in for x, we get 3 out for y. And if we put 2 in for x, we get 9 out for y. Okay, let's do the logarithm. So remember I said how the input of one becomes the output of the other? So remember, if we rewrite this log base 3 of x, which remember f of x is the same as y, so if we rewrite this as an exponential, we have 3 to the y equals x. So we're going to put numbers in for y, and let's put the same numbers in that we did when we did our exponential, but they go in for y, and this time we figure out what x is. So 3 to the y is x. So if y is -2, then x ends up being 1/9 again. If we put -1 in for y, x is 1/3. If we put 0 in for y, x is 1. 1 in for y means x is 3. And 2 in for y means x is 9. So let's graph both of these. So if we do the first one, x is -2, y is 1/9. That's pretty close to the x-axis, but not actually touching it. Then we have the point -1, 1/3, 0, 1, 1, 3, and 2, 9. So you should recall from graphing this in the last section that it goes kind of like this. And remember, it gets very, very close to the x-axis as we go negative. It just never actually touches it, regardless of what my bad drawing looks like. So that one is 3 to the x. Now let's graph log base 3 of x. So this time when x is 1/9, so very, very close to the y-axis, y is -2. When x is 1/3, y is -1. When x is 1, y is 0. When x is 3, y is 1. And when x is 9, y is 2. So this one looks like that. And it keeps curving up this way. So if you look at these two, if we were to fold our paper on this diagonal, sorry, that is not a very good diagonal. But if we were to fold the paper on this diagonal, going right down through here, they would line up against each other perfectly. So now, we talked about the domain and range of the exponential function in the last section. Let's just look at the log function. What is the domain? Remember, domain is x values. So the smallest x value we can get is as close to 0 as possible without being 0. So that's why it's a parentheses. And the x's can keep going to infinity. Now, what's the range? Well, for the range, we talk about all the y values. So this one keeps going down to negative infinity, and it keeps getting larger and larger and larger, so it goes to positive infinity. Okay, let's look at another one. And you should try this one on your own. So pause the video, and when you think you've got it, you can restart the video and we'll see if you're right. So for this one, we're going to graph f of x equals 2 to the x, and f of x is log base 2 of x. So if we fill in our tables, when x is negative 2, y is 1 over 2 squared, again using our rules of negative exponents, which is 1/4. When x is negative 1, y is 1/2. When x is 0, y is 1, because anything to the 0 power, remember, is 1. When x is 1, y is 2. And when x is 2, y is 4. Okay, let's rewrite f of x equals log base 2 of x as an exponential. And remember, f of x is the same thing as y. So we have 2 to the y equals x. So our y values, let's just pick the same things we used as x on the previous table. So when y is negative 2, x is 1/4. And you should be able to see that this is going to work out exactly like the previous problem, where the x values for the exponential 2 to the x become the y values in log base 2 of x. And the y values from 2 to the x become the x values from log base 2 of x. So if we keep going, when y is negative 1, x is 1/2. When y is 0, x is 1. When y is 1, x is 2. And when y is 2, x is 4. And now we can graph these again. So let's see. Graphing the 2 to the x first, we have negative 2, 1/4, negative 1, 1/2, 0, 1, 1, 2, and 2, 4. So if we draw our graph, and remember it keeps getting closer and closer to the axis without actually touching. Now let's do our log base 2. So when x is a quarter, y is negative 2. When x is negative 1, when x is a half, y is negative 1. When x is 1, y is 0. When x is 2, y is 1. And when x is 4, y is 2. So again, we have this curve that gets very close to the y-axis but doesn't touch it. So should label these. Here's 2 to the x. And here's log base 2 of x. And again, you can see if we fold the paper on this diagonal running through here, that if I could draw better, they would line up perfectly on each other. So let's briefly talk about the domains and ranges of these. The domain of 2 to the x, hopefully you can see that x can go from negative infinity to positive infinity. And the range, remember it can't get all the way down to the x-axis, so it's 0 to infinity. The domain of log base 2 of x, x's can't be 0. They can get really close to 0, but they can't get there exactly because remember it never touches the y-axis. And the x's can get as big as we want, so they go to infinity. The range is all the possible y values. So that's negative infinity to positive infinity. So what you should notice here is that the domain of 2 to the x is the same as the range of log base 2 of x. And vice versa. The range of 2 to the x is the same as the domain of log base 2 of x. Okay, that's it for this video. There will be one more very short video just to do a couple of application problems using pH.